In this video, we are going to talk about even, odd, or neither functions. So this is a type of way in which we categorize functions. And the basic three types are even functions, odd functions, or if they are not even or odd, they can be called neither. So even functions, the definition is listed here that even functions are symmetric about the y-axis. So what does that mean? Let us say we have a function y equals x squared. So the graph of this parent function of a quadratic graph would be like a U-shaped graph. So what does it mean by symmetric? Symmetric means that this section is equal to this section, or the function is equally divided about the y-axis. This is the y-axis or f of x axis, and this is the x-axis. So as you can see, if we fold the function, it is going to symmetrically fold about the y-axis. Hence, these functions are called even functions. Let us see some more examples. So the next one is, let us say we have f of x equals 3. Now constant functions are also even. Let us see why. Can I write this as, instead of f of x, I can write this as y. So it becomes y equals to 3. Now let us see how we can graph the function y equals to 3. Now for y equals to 3, see, there is no x over here. There is no y equals mx plus b form. It is just the number 3. So this is 1, this is 2, and this is 3. So let us draw a line across the number 3. And as you can see that this function is also symmetric about the y-axis. If I fold it, it is going to symmetrically fold across the y-axis. Hence, this function is also even. So we can say that all constant functions are also even. Constant functions are even. All right, let's take a look at another even function, which is the absolute value function. So in the absolute value function, I would like for you to highlight this v here, because that's the actual shape of the function. And how do we write the absolute value function? I can write it as y equals absolute value of x, or another way of writing it would be f of x equals absolute value of x. So let us see how the graph will be. If we graph this function, we will have a v-shaped graph, hence the letter V was highlighted. So the V-shaped graph is going to be something like this. And as you can see, it is also symmetric about the y-axis. So remember, any functions that are symmetric about the y-axis are going to be even functions. So this function we can say is also even function. All right, let's take a look at more examples. Next one, we have f of x equals x cube. Now, as you can see, the power is not even, it is an odd power here. So such type of functions are called odd functions. When the power is an odd number. And the main characteristic or property of an odd function is that they are symmetric about the origin. So the origin is what? The point 0, 0, where x and y are meeting. Let us take a look at an example of an odd function. Let us say we have y equals x cube, the one that I wrote it down up there. So the graph of the function, let's take a look at the graph of this function. The graph of this function is going to be something like this. It's like an S-shaped graph. So this function is symmetric about the origin. So as you can see, this is quadrant 1 and this is quadrant 3. So quadrant 1 and quadrant 3, the graph is symmetric about those two quadrants. So such type of functions are called odd functions. because it is symmetric about the origin. So with odd, you can say origin, O for odd, O for origin is what you can use to remember. All right, let's take a look at another example. Let us say we have y equals x. So if I have y equals to x, can I say that the power of x is 1? And what type of number is 1? 1 is an odd number. So we can say that this function could be an odd function. Let us see how the graph of this function is. When we graph it, it is going to go through the origin point 0, 0. And as we can see here by the graph, that this graph is symmetric about the origin. It is symmetric about the origin, hence the function is an odd function. All right, let's take a look at another example. This time I'm just giving you a graph here. Let's see, we have a graph of a function. Now this function is symmetric about the x-axis. So the function is not even because it's not symmetric about the y-axis. For it to be symmetric about y-axis, we could have a shape like this, which it is not. Now for it to be symmetric about the origin, we could have gotten a shape like this, which is it is not. So whenever you have functions like this, they are called neither. If they are not even or not odd, they are called neither functions. So this is neither. Let's take a look at another example. So this type of function, let us take a look at the graph of the function. This is the y-axis. And it is actually symmetric about the y-axis because this is area is equal. I can fold the function about the y-axis. So remember, for it to be symmetric to y-axis, the functions are even. All right, another example or another graph. Let us say we have a function something like this. So it's an up and up function for end behavior. This is the y-axis. It's not drawn to scale, but I hope you get the idea that the function is symmetric about the y-axis. So if I'm folding the function, this area and this area is similar. So I can say that this function is even in nature. All right, so I'm going to give you a little assignment as we are at the end of this video. I would like for you to graph the given functions and find out if they are odd, even, or neither. So you can graph the functions to get your answer. And the question is, determine if the functions are even, odd, or neither. So let's write down the questions related to it. The first one is f of x equals x cubed minus x squared plus 4x plus 2. So you can just graph the given function either on your calculator or Desmos, and you can see the shape, and from the shape determine what type of function it is going to be. Next one, f of x equals negative x squared plus 10. Third one, f of x equals x cubed plus 4x. And the fourth one is, we can say y equals absolute value of x plus 4. So graph these functions and find out